Hi there, this lesson I'm going to teach you how to prove divisibility by mathematical induction. So let's get started. To prove this statement is divisible by 7, so step number 1, we need to prove for n the smallest number first. In this case, the smallest number for n is 1. So let me write it down. So this means that n is replaced with 1. So that is 8, 2 times 1 plus 1 at 6, 2 times 1 minus 1. So 2 times 1 is 2 plus 1 is 3. So that is 8 to the power of 3 and then 6 to the power of 1. Because 2 times 1 is 2 minus 1 is 1. So that is 6 to the power of 1. So now I just put that in a calculator. So I just go 8 power of 3 plus 6, which is 518. So if I divide by 7, see what happened? Which is divisible by 7. So that is equal 581. The next step is we assume that it is true for n equal k. So in another word, we replace n with k. Assume so that is so because the statement is true for divisible by 7, in another word, it is a multiple of 7. So I can write 7m or 7p, doesn't matter. So I just write 7m. Then we need to prove it is true for n equal k plus 1. So in another word, we replace n equal k plus 1. So it's 8 to k plus 1 plus 1 plus 6 to k plus 1 minus 1. That's what I meant, okay? So I just write it down here. Proof for n equal k plus 1. So now we just replace n with k plus 1. So that is 2. So what I do now is I just remove the bracket, okay? So that is equal to, so 2 times k is 2k and 2 times 1 is 2. So which is 8, 2k plus 2, and then we add the 1, don't forget. And then similarly, 2 times k is 2k, 2 times 1 is 2. So add 6, 2k plus 2, and we just write it down the minus 1. Now, instead of I simplify, what I do, I just rearrange in order. So that is 2k plus 2 plus 1. I can rewrite this as 2k plus 1 plus 2. Okay, I just rearrange it. That's all it is. So which is equal to 8, 2k plus 1 plus 2 plus 6, 2k minus 1 plus 2. So we also know that a power of m plus n is equal to a power of m times a power of n. In another word, 8 power of 2k plus 1 plus 2 is exactly the same as 8 power of 2k plus 1 times a square. So a square is 64. So in here is equal to 8 power of 2k plus 1 times 8 square. And similarly with this one is exactly the same as this, okay, times by 6 square. But a square is 64, so this will give me 64 times 8 power of 2k plus 1. And we add 6 square is 36. So which is 36 times by 6 2k minus 1. Then what I do now is let's go back to this statement here. So we can either rearrange these equations to make 8 power of 2k plus 1 as a subject, or I can make 6 power of 2k minus 1 as a subject. Doesn't really matter. But let's make 8 power of 2k plus 1 as a subject, okay? So this becomes, I move this on this side, so that means 8 power of 2k plus 1 is equal to 7m minus 6 power of 2k minus 1. So now I replace this with this, okay? So that is equal to 64 7m minus 6 2k minus 1 plus 36 times 6 2k minus 1. So now I just expand it out and then I simplify. Okay, so these time together, I'm not going to work it out because I'm going to take out 7 anyway as a common factor. So I just write this out first. So 7 times 64m, or 64 times 7m is the same. So minus 64 times 6 2k minus 1 plus 36 times by 6 2k minus 1. So that is equal to 7 times 64m minus 64 plus 36. So just go 64 minus 36. So which is 28. So 28 times 6 2k minus 1. So now the common factor is 7. So I take the 7 out. So 7, 64m minus 4 times by 6 2k minus 1. So which is divisible by 7? Which is divisible by 7. So now we can write the statement. Therefore, it is true for n is equal to k plus 1. So we write the last statement. So therefore, the statement is true for all n greater or equal to 1. So there you go. Please pause the video and try this one yourself. Hi, I'm back. Let's go through this together. So step number 1, we need to prove for n equal 1. So this means that we replace n with 1, right? So that becomes 2 power of 3 times 1 minus 3 power of 1. So that means become 2 to power of 3 minus 3 to power of 1. So which is 8 minus 3, which is 5. Which is divisible by 5. The next step is we assume that it is true for n equal k. In another word, we need to replace n with k. So that is 2 power of 3k minus 3 power of k. Okay? So we need to write down, assume it is true for n equal k. Because the statement is true, in another word, it is multiple of 5. So I just write equal to 5 times a number. I just make it m. And then we need to prove for n equal k plus 1. So now we just need to replace n with k plus 1. So this means that this becomes 2, 3k plus 1 minus 3k plus 1. Okay, so just write this down here. So the statement becomes 2, 3 lots of k plus 1 minus 3k plus 1. So now I just expand the bracket out. So this becomes 3k plus 3. So 2 power 3k plus 3 minus 3k plus 1. Now don't forget 2 to the power 3k plus 3 is the same as 2 to the 3 power k times 2 to the power 3. Don't forget that, okay? So this is same as 2 power 3 is 8. So it's 8 times 2 to the power 3k. That's what that meant. So I just write underneath here. So that will give me 8 times 2 to the power 3k minus similarly this one, so which is 3k times by 3 power 1, so which is 3. So that will give me, I'll just move this up here. So 8 times 2 to the power 3k minus 3 times 3 to the power k. Now from our assumption, this one here, we can either make 2 to the power 3k as a subject, or I can make 3 to the power k as a subject. But because with negative 3 to the power k, easier if I make 2 to the power k as a subject. So I move this on the side, becomes positive. So that is 2 to the power 3k is equal to 5m minus become plus 3 to the power k. So now all I need to do is I replace this with this, okay? 2 to the power 3k is equal to 5m plus 3 to the power k. So I just rewrite this statement out. So which equal to 8 5m plus 3 to the power k minus 3 lots of 3 to the power k. Then all I need to do now, I just simplify by expand the bracket first. So which equal to 5 times 8 is 40 m plus 8 times 3 to the power k minus 3 times 3 to the power k. So now I just collect like terms. So 8 apples minus 3 apples is 5 apples. So which is 40m plus 5 lots of 3 to the power k. Now the common factor here is 5. So I just need to take the 5 out. So which give me 5. So 8m plus 3 to the power k. Then it is divisible by 5, which is divisible by 5. So I just write therefore. So therefore it is true for n equal to k plus 1. Then the final statement is conclusion. So I can write therefore the statement is true for all positive n greater or equal to 1. There you go. Thank you so much for watching. Bye.